Welcome to the Talent Talks podcast from Embry-Riddle Aeronautical University. I'm Alan Caesar. My guest today is Nolan Coulter. He's co-founder and chief technology officer at Modularity Space, a company based out of Embry-Riddle's Microplex in Daytona Beach. They're developing low-cost, modular, reusable satellites that can be repaired, refueled, and upgraded in space. They also offer end-to-end mission delivery services. Nolan earned a bachelor's from Georgia Tech in 2016 and a master's from Embry-Riddle in 2018, both in aerospace engineering. He is currently pursuing a doctorate in aerospace engineering at Embry-Riddle. Nolan, thanks for joining us today.
Yeah, thank you for having me.
So tell me a bit about Modularity Space and what it's all about. What do you guys excel at?
Yeah, so modular space is really built around the principle of future on-orbit servicing technologies. Modular space actually used to be a on-orbit servicing manufacturer looking to actually get into building robotic spacecraft to actually go up and, change out different parts on a spacecraft. And we really quickly realized once we got into the industry that the future wasn't necessarily robotic systems. It was developing a satellite that could be repaired on orbit. Most satellites today, all 3,700 of them that are currently in operation, none of them are actually designed to have components replaced. None of them are designed to necessarily be refueled. And so that's where we're really trying to step into the market and provide such a satellite.
Yeah, so and part of that is sort of standardizing satellite systems. Um, how does that work? So is there already a refuel repair infrastructure up there, or does that come later?
So we're already starting to see in the industry a lot of development in that area. Northrop Grumman just last year had their very successful mission extension vehicle mission that actually had a robotic servicing satellite go up to a defunct satellite. I believe it was Intelsat 901. And they docked to it and actually moved it back into service. So that was really the first commercial success for demonstrating on-orbit servicing. And we also see a lot of money being put into a company called Astroscale that's also looking to bring into market their first on-orbit servicing system as well. So we're already starting to see the market kind of shift in that direction of on-orbit servicing satellites, but we still don't actually see any satellites taking the proactive approach of being repairable.
Okay. So tell me a bit about like sort of standardizing satellite systems. I imagine there's the old engineers joke that like the great thing about standards is there's so many to choose from. What how do you create a standard that people actually follow?
That's definitely a very difficult problem because you hit the nail on the head. There are a lot of standards within the industry, and not only just on processes, but on the actual mechanical interfaces, the size constraints, the power constraints. So all of these different things are really difficult to try and pinpoint because there's really no master of one. There's just a whole bunch of different usable components and hardware. So we've actually been doing a lot of investigation into the industry as to what is the biggest hindrance or impedance to actually developing a standard across the industry. And unfortunately, the biggest problem is that most aerospace industries today are vertically integrated, meaning that they do everything in-house. They develop all their different components, so they have full control over what they want to implement. There is a really cool standards organization within the aerospace industry called CCSDS that we've been looking to adopt a lot of their components because they've already done a lot of the current investigation into what standards could be out there. So we're really trying to push that sort of standard of actually using an open standard, one that's already has flight heritage, that's already seen implementation. And so we're really hoping that our standard, pushing that envelope, could actually be adopted by the industry as well.
Okay. So reusability is part of it. How do you go about reusing these systems? Is that more about like sort of the main chassis and the individual components can be changed out, or you're not actually like bringing this stuff back down to then launch back up again? Are you?
So we have a roadmap or a plan, if you will, that kind of has the 1 year goal, the 5 year goal, and then the 10, 20-year goal. So the really short term goal here is developing a satellite that actually has the ability to be rapidly manufactured on Earth, because that can be directly scaled into rapid replacement on orbit. So if you think about it, like how cars are developed, everything is developed in sub-assemblies. They are easily integrated by robots. We're trying to push that same manufacturing technology for satellites, because then that means that robots can actually then repair and take subsystems off while in orbit. And then, so that's really kind of the stepping stone. First, make sure that we can manufacture the satellite in a modular way here on Earth, and then develop the technologies down the road for robotic manufacturing or changing out of components in orbit.
So are most satellites built by hand today?
Yes, most satellites are built by hand, or they might have some sort of automation, but most of it is done by skilled workers for the actual mechanical development. Yeah.
Huh. Uh, so you have an interest in sustainability, and there's a large amount of space junk in low Earth orbit. Um, satellite, the old decommissioned satellites, other debris that's floating around out there, um, and that's becoming more and more of an issue as sort of lots of companies are getting into space. It's not just the realm of a few individual nations anymore. Do you have concerns about that when you're planning your missions? Is that part of the reason you're designing these to be reusable?
That's exactly right. The industry already sees a major push for trying to help situational awareness, because you're right, we do have a lot of space debris, a lot of defunct satellites. I think there are like close to 8,000 overall satellite systems in space, but only 3,700 of them or around there are actually functional. So there's a lot of debris and clutter up there. So we really want to take the proactive approach, and even if we can't necessarily quote unquote reuse the system, as in like bring it back down to earth, retrofit it and send it back up, we would at least like the capability of replacing hardware, because battery systems, computer systems, even payloads, all that hardware over 10, 15, 20 years can become obsolete or even just completely uh, stop working. So we want to be able to replace those systems, those individual systems, to then extend the life of the satellite and avoid having it just go dark.
So repairing them in orbit would be sort of a standardized, robotic satellite, or are you picturing like the space station docking with these individual satellites and fix them up, a astronaut fixing them up?
So that's definitely something that we want to get into probably in the next 5 years, is understanding what infrastructure we could utilize that's already existing. The International Space Station was originally developed in order to handle servicing of satellites in orbit. That was the big goal of the STS program as well. But we also, as I mentioned, there's a lot of development happening in the industry today for robotic services, both in low Earth orbit as well as in geostationary orbit. So we're hoping that somewhere along the line, if it's not up to us, hopefully we can actually integrate other companies' technologies for servicing.
So what does refueling a satellite mean? Is that new batteries? Is there like other stuff that you need to refuel?
So primarily what's meant by refueling is actually filling up the tanks again. A lot of satellites use some sort of propulsion system for station keeping its orbit operational, because even in low Earth orbit, as high up as it is, there's still atmospheric drag, so the satellites do decay and actually can fall back to Earth over time. So a satellite's always using some sort of propulsion, whether it's for changing its rotation and attitude, or actually keeping its orbit above falling back into Earth. So we hope to be able to have a standard system, and NASA's actually already working on this, to have any sort of robotic servicer be able to dock to it and refill its tanks for propulsion.
Oh, right. Everybody's got to have the same connectors, right?
Exactly. And that's actually something NASA's been working on. And this goes back to what I was originally saying, where no satellite's actually designed to be serviced, is because NASA's been working on a robot servicer, I think called Restore L. Um, and their system for refueling has to have pliers and wire cutters. It has to have, the actual hose for connecting to the satellite to refuel it, because originally speaking, satellites were filled up one time, and then it was just expected that after it ran out of fuel, that's it. So they're still not designed to actually be refueled. So we have to develop that system as well.
Okay. So you guys have been working on a CubeSat system as well as a larger ESPA class satellite system. What are the differences between these two? And I don't even know what ESPA means. So
Sure.
so help me out a little bit.
Yeah, so CubeSat are very, very popular. They started originally back in the early 2000s and then got heavily adopted in the around 2011, 2012 period. And they are one of the first standards within the industry for a satellite bus. They are built around a 10 by 10 by 10 centimeter cube structure, and you can make different volumes by integrating more and more of these cubes together. So it's a really nice standard for, a lot of demonstration missions and a lot of university missions actually use this standard because everything is actually built around this volume. So that's actually a really cool standard that's seen wide adoptance. And I think a lot of it is because it was open source to begin with. Anybody could just go and download the manual for how to build a CubeSat, and there you go. So it's definitely a really cool entry into market capability. Most CubeSats can come into a 1U range. One unit is the 10 by 10 by 10 centimeters. And
Okay.
then you can also have different configurations like a 3U, a 6U, a 12U, all of these different standards that just have more and more of these cubes built together.
You guys have like a
And
16U. Is that right?
exactly, yes. So
Okay.
that's basically a 4x4U system all put together. So you have 4Us by 4Us um, that make up that 16U. The difference between the CubeSat class is that they're typically around the order of 1 kilogram for a 1U system, maybe upwards of 20 kilograms for a 16U system. And the ESPA class is a much, much larger satellite. We're talking somewhere on the order of 180 kilograms. That difference alone allows it. The ESPA class satellite is really another standard in terms of size, but there's still no standard for like the volume for how to actually construct your satellite. So that's really what we're trying to get into as well, of developing a standard ESPA bus, a standard ESPA satellite that handles all of the complexities of designing a satellite from the ground up.
Okay. Um, so 10 by 10 by 10 centimeters.
Yeah,
That's like a 4-inch square. That's not very big. What can you do with that?
exactly. Originally, it was thought that you couldn't do very much. And you really can't do very much when you talk about one U CubeSat. But what we're actually starting to see today is that a lot of university missions and even company missions are expanding that to develop a constellation, meaning having multiple satellites of these 1Us, and that they can talk together and they can actually do a much larger mission having multiple of these 1Us versus just one satellite that might be larger to handle the same mission.
Okay, so what kinds of projects is Modularity Space looking to be sending up? Are these like mini automated research labs? Are they communications modules? What do companies want to get into space for?
So one of the things that we've really seen and identified as a good entry into market is demonstration missions, whether that's university payloads. We've actually talked to the Prescott, ERAU Prescott, about a system that they want to actually send up into orbit. A lot of demonstration and university payloads are looking for really low cost access to space. And we think that our standardized system really provides that low cost access for them. So we've talked to other companies as well looking to demonstrate communication systems, Earth imaging systems, and really, since our satellite is a little bit larger, it's on the 16U class scale, we can fit all of them on one mission, which means that, again, we avoid the probability of space debris because we're taking, something like 4 to 8 satellites and putting them all together in one. And we're really seeing a dramatic cost reduction because all 4 of those payloads are all sharing the same space. And so that means they're sharing the same launch cost, they're sharing the same communication cost. They're basically doing a massive cost sharing sort of setup that really reduces the overall price.
Okay, good, good. Yeah, I was going to ask you about the ride sharing thing that you've got it mentioned on the website. But I was also reading about your your click and go design, and that it's so hardware agnostic in terms of what somebody might want to mount to sort of your standard rack. Give me a little bit more about why that's important to someone wanting to send a payload up and how it works.
Yeah, absolutely. So that's part of our host design, what we're calling our host vehicle. That's that
Mhm.
larger ESPA class satellite.
Okay.
And we've designed a preliminary design of the satellite that allows components, like actual compartments, to be separated from the vehicle and have new components inserted back into the vehicle. And we've called this the click and go satellite, because literally you can unclick, or you can kind of separate a component out and then click it right back in, to where it'll be mated back to the vehicle. And so that's really our first design and our first take on what a modular reusable satellite could look like, because you can imagine that if, separate the idea of just having payloads, but we can also have computer systems, batteries, we can have our thermal system in there, in these different compartments that can be swapped out on orbit.
Okay, okay. I built some desktop computers back when I was younger, and like I picture pulling out an old VGA card or something. Is that kind of the idea?
That is the exact idea. We've developed a tray system for the satellite that all these different components can slide in on a tray and then slide back out on a tray, and you can swap out all the hardware inside.
Are you saying I'm qualified for space work? Like I
You
could be
might
a
be, absolutely.
All right. Well, I'll hit you up after the call then. No, I'm
Perfect.
kidding. Um, so, Modularity Space got you guys got a small business innovation research grant from NASA to develop space system communication technologies. What work are you involved in for that, and what does that grant mean for you and your company?
That grant was really, really big for us because it's really been a validator for what we've been working on. The longest time, it's hard in the aerospace industry because the aerospace industry is naturally prone to be cautious when developing new technologies and new ideas. That even stems to now what we see with SpaceX. SpaceX is still butting heads with certain contractors because they have such a radical new idea on how to handle launch vehicles and how to handle satellites.
Mm.
And it's just inherently the same because the aerospace industry is small and components are, traditionally very expensive. And so trying to get new technology into orbit is also very expensive because you have to mitigate all of the problems of these new technologies, right? You have to basically convince everybody that you're worth it. And that's really what NASA gave us in terms of this SBIR proposal, is because we've been developing all these different technologies to enable this rapid response vehicle, this rapidly robotically assembled vehicle, and this communication system is really at the heart of that capability. And so it's just been a big validator for us for trying to make sure that we now know that we are definitely on the right track, and there is a space for us within the aerospace industry.
So, tell me a little bit more about that sort of that communication technology at the heart of this thing.
Yeah, so this goes back to our original short discussion about the standards within the industry. And one of the
Mhm.
biggest things that you'll find when you're trying to develop a satellite is that every component, every payload, literally every connection in the vehicle has a different connector. So like an outlet on the wall, right? Every home
Mhm.
is standardized in America with the same plug and outlet. But on the Aris, on an actual satellite, it's like taking the entire world of outlet plugs and putting them into a small satellite. Everything is different. There's usually only a couple of payloads that might follow the same plug, if that makes sense.
Oh, because they're all, like, individually built and by hand and to their specific mission, and so none of it's standardized.
Exactly. Or they actually follow different standards, as we said before.
Right, 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 yeah.
So we're actually developing with NASA as part of this SBIR grant, a system that can do away with all of those hardware connectors. And we're talking about now communicating wirelessly, which is a big, big, big step
Uh,
forward for being able to swap out components in orbit.
so, I imagine that's like, all cars reaching some sort of fuel efficiency standards. There'll be still a bunch of old cars on the road that are still gas guzzlers or whatever. Like, at what point do all the satellites then meet this standard? Is there, like, do you have any idea of, like, is that 10 years, 20 years, 50 years?
Yeah, I think a lot of that, we're really starting to do a lot of industry outreach now, now that we've gotten this SBIR. And I think there's just too many variables to really tell, because I think one of the biggest reasons that we've seen as to why a standard hasn't been adopted to date is because, as I said before, every company is doing everything individually. There's really not a single collaboration of these companies to just say, hey, that one's a good one, let's use that. And I think another big part of that is because a lot of standards are not open source, meaning that you have to pay proprietary, licensing fees to actually use the standard, or, it's not necessarily an easy thing to adopt. So we really hope to develop an open standard that allows these payload developers and component developers to actually develop their system around that communication standard. So we're really hoping that, even if it'll definitely be slow, as we've seen most standards within the industry take anywhere between 5 and 10 years to be not adopted, just to be approved as a standard. So it's definitely going to be a long time before we see any sort of standard adopted out of this, but we definitely think we're on the right track.
Okay. Uh, so talking a bit about the launch side of this, I know you've done some work on reusable rocket systems in your career, and you know a bit about orbital mechanics and control systems. Do you have any plans eventually to maybe send up your own rockets? Because you're just getting on, hitching a ride on like SpaceX and so on, right?
Yeah, that's right. Really, within our roadmap right now, we rather leave the complexities of launch vehicles to other currently established developers. One thing that I really have seen a lot of recently is there's like over 165 launch vehicle developers currently in active funding.
Oh
That
wow.
a lot of those is small launch vehicle developers, your people like Electron or Relativity Space, and then of course you have your big competitors like ULA, Northrop Grumman, SpaceX, of course. And there's just so many people trying to fight for the small number of satellites that are going up, that at least right now it doesn't really make sense for us to try and shift gears and take on the big problem of rocket launches. So we're happy with the direction SpaceX is going and reducing those costs, and happy to take a ride share there.
Yeah, yeah. Well, I imagine there's a pretty hefty, R&D cost to come up with a rocket, and then the materials cost to build it and then prove it out, and that has a big hurdle to clear.
There's definitely a big technical hurdle when developing a new rocket system, but what a lot of people don't necessarily think about is also the big business hurdle, because as a small startup company in the aerospace industry, you really need to find investors or some sort of capital to get your technology moving. And when you're talking about business with a new technology, you have to have something that's kind of like your quote unquote secret sauce, something that differentiates yourself from all of your competitors. And when you're talking about something as complex as a launch vehicle, when you have 165 competitors in the launch space, it's really hard to find that secret sauce that brings in those competitors to you, as well as customers. So yeah, we're definitely happy with just having SpaceX do the hard work for us, or other companies do the hard work for us there.
All right. So in your education and career, what was the first project that you worked on that got sent into space?
Yeah, so as an undergrad at Georgia Tech, I was a member of the guidance, navigation, and control team for the PROX-1 satellite mission. That was a AFRL, or an Air Force funded project, and it was designed to actually house a smaller CubeSat inside of itself. That was a planetary society CubeSat called LightSail, and it was meant to go up on orbit on a SpaceX rocket, and then deploy that that cube satellite, and actually do what's known as proximity operations, meaning that it takes pictures of it, it goes up to it very closely and makes sure that it's deployed correctly, and then it kind of follows it on orbit. So I was a member of that team, and that launched actually just last year, I believe in June of last year, on the STP-2 mission.
Yeah, how's it feel to watch that rocket go up with something that you worked on it?
That was absolutely incredible experience. It was definitely a long project. I mean, I was on that project for a couple of years, and then with everything going on, somewhere along the line, there were technical hurdles that pushed the schedule back. Then also SpaceX had technical hurdles because they were trying to get their Falcon Heavy working, which is what it was supposed to launch on. So everything in terms of the schedule got pushed down the line, and just finally seeing 4+ years of work finally get on orbit and actually work was definitely the coolest experience ever.
How did you get into wanting to pursue this as your career in the first place and wanting to send stuff into space?
That is a definitely a long, not necessarily a long story, but every time I say it, I always feel like this is out of a movie. But it originally started this passion of following the aerospace industry when I was a freshman in high school, and I actually saw the Blue Angels perform over Charleston Harbor. I'm originally from South Carolina, from Charleston, South Carolina, and they were supposed to perform at the Air Force Base there. But I don't exactly remember why or the story behind this, but the city basically shut down the air show, told them that they couldn't perform there. There was something else going on. And instead of canceling the show altogether, they actually just performed the show all over Charleston Harbor, a massive harbor that's there. So we all just went down to the beach and watched the planes do all their acrobatic stunts. So that was really the first thing that kicked me into thinking about aerospace engineering as a profession. I've always been, I've always loved trains, planes, and automobiles. The space shuttle I grew up with, I remember, seeing Columbia and Atlantis and Discovery flying on several missions and even coming back. And all of that just really kind of pushed me in that direction. And that's where I applied to Georgia Tech for their aerospace department and was accepted. Loved all of my classes and courses, and finally kind of found that niche of narrowing it down from the entire aerospace industry to just space. And then I got on the Prox One satellite team, fell in love with that, and knew that I wanted to continue satellite development and actually working on satellite space systems, and found my way to Maston, and then the rest is history from there in terms of getting into graduate school at Embry-Riddle and finding Modularity Space.
Right on. Tell me about your Twitch account.
Yeah, sure. So I stream live on Twitch. I haven't recently just because of the schedule and time management. I talk space all the time, but I do love finding outlets to provide STEM outreach and have fun and interact with the STEM field and community. And so I have a channel on twitch.tv and play games, do educational content, even looked into doing an open source, satellite demonstration for everybody in the STEM community. And yeah, just I can't get enough of space, so finding an outlet.
That's a lot of fun. That's a lot of fun. You got a lot of followers. You got big famous sponsorships lined up.
Not yet, not yet. That's the dream. I don't stream enough to be able to get that lucky yet, but maybe one day.
All right, all right.
Maybe once Modularity Space sends up their first satellite, we can start that channel process.
There you go. Well, you've sent stuff into space, so you're like well on your way as far as like my childhood dreams. Like you're well beyond me. So I think you're doing all right.
I appreciate it.
But it's nice to hear that you still have dreams, beyond that. So, all right, Nolan. So we're going to take a short break, and then we'll continue on to the lightning round. Hey, Talon Talks listeners. We'll continue to the lightning round in a second, but first I wanted to tell you about the business directory for Embry-Riddle alumni. We know it's a tough time to be an entrepreneur right now, but small businesses are the ground floor of ingenuity, and we want to help promote yours to fellow Eagles. So whether you run a business out of your home or your garage, or you're the founder of a multinational organization, we applaud you and we encourage you to list your company with us in the Eagle Entrepreneurs Business Directory. There you can list your business name, describe what you do, provide your logo and link to your website, as well as your contact information so that other Embry-Riddle alumni can find and support your enterprise. If you're not a business owner but are looking for someone to help you with aircraft insurance, or need an electrical contractor, a realtor, printing services, portrait photography, a triathlon coach, or just looking for a good bike shop near you, there's probably an alumnus or an alumna who does it. You can find all this in the Eagle Entrepreneurs Business Directory. I encourage you to go there. It's at alumni.erau.edu/business. Thanks. All right, now it's time for our lightning round. I'm going to give you 5 questions and you're going to give me 5 answers. Are you ready?
I'm ready.
All right. If you can send any sort of satellite into orbit to do anything that you want, doesn't have to be realistic or feasible with current technology, just a whatever you can imagine kind of thing, what do you choose?
Oh, that is a great question. And maybe I'm biased, but I would definitely love to have an on-orbit servicing satellite in orbit, and one that can really do everything that on-orbit surfacing, right, has been kind of like the nuclear fission of technology for space. We've always been a decade away. It's always been something we've been working on, and actually seeing a fully usable, reusable on-orbit surfacing vehicle would just be awesome. But I might be biased there.
Fair enough. I mean, I would probably just send like a container full of like tubes of toothpaste just to see what would happen, but that's just me. Uh, so if you could read only one book for the rest of your life, what would it be?
I would have to probably say this is a classic, but Rendezvous with Rama. It's a science fiction book that I really, really enjoyed. That was, I don't know, it was just really interesting talking about. It was placed in the future of space travel, and humans for the first time encountered not aliens per se, but just an alien spaceship that was devoid of life. And they talk about rendezvousing with it and exploring the technologies that they had. And I think it's an entire series, but I haven't finished the series yet.
Interesting. So like sort of space archaeology.
Yeah, exactly. It was a really interesting take, and I think it's an old book too, like a true classic, like 1980s or something like that. I could be wrong.
Wow. Some of our alumni are going to be offended that you call it something from the 80s a true
I
classic.
meant I meant more of a classic in terms of like classic movie, something you have to read in terms of science fiction.
Right. Of course. Of course. So who's your favorite cartoon character?
That would definitely have to be Bugs Bunny.
Right on. Right on.
Absolutely.
Uh, so picture your ideal grilled cheese sandwich. You got this in your hands. You're about to take a bite out of it. What's in that sandwich?
For me, for grilled cheese, definitely 4 cheese Mexican blend, a little bit of barbecue sauce and sriracha.
All right. What kind of bread do you use?
I'm a fan of just plain old white bread.
Yeah. Sriracha's a nice touch. I don't think I've heard that one yet. That's good. So if you could live for a week as any person in history, who would it be?
Probably Werner von Braun. Um, Definitely somebody that I would definitely want to meet and pick his brain. The father of the Apollo program and the Saturn V rocket, NASA administrator for a long time as well. Definitely interesting to step in his shoes and see what he saw.
All right. That wraps it up. Thanks very much, Nolan, for joining us for the Talent Talks podcast.
I appreciate it. Thanks for having me. It was a good time.
All right. Talent Talks is a production of Wicked Radio and the Embry-Riddle Office of Philanthropy and Alumni Engagement. We're coming at you from my office at Embry-Riddle Aeronautical University in Daytona Beach, Florida. And Nolan, where are we reaching you?
Yeah, I'm here at home in Daytona Beach as well, right behind the mall in Daytona Beach.
All right. So this episode was recorded by me and edited by Cindy Puckett. Edmund Odarte is our program manager. Bill Thompson is executive director of alumni engagement, and Tony Brown is executive director of communications. If you'd like to share your thoughts about our show or suggest a guest to us, we'd love to hear from you. Visit alumni.erau.edu/podcast and click the feedback link. I promise your message comes directly to me. Thanks for downloading us. We'll see you next time.